It all begins with three simple but serious problems that have plagued regional air travel for decades. Rough cabin vibrations that make passengers uneasy, constant maintenance delays that throw schedules into chaos, and the roaring turboprop engines that shatter the peace of early morning and late-night operations. These have been the everyday pain points of short-haul flying, and now Tesla wants to erase them completely. Imagine an aircraft that doesn't crawl down a long runway, but instead lifts vertically like a drone, rising straight into the sky with the grace of a feather. That's the promise behind Elon Musk's 2026 Tesla Super Electric Plane, a vehicle designed from the ground up to redefine short-haul travel. Musk has often teased the idea of an electric aircraft capable of vertical takeoff, landing, and even supersonic speeds. The Tesla Super Electric Plane is now positioned as that long-awaited breakthrough, a machine that directly tackles every flaw of today's small-range aviation while signaling the beginning of the end for old short-haul jets and regional turboprops, as Musk puts it. Tesla's goal has always been to create things people genuinely love, not products that feel forced or corporate. The Super Electric Plane embodies that principle. It's tight, efficient, deeply practical, a 4.2 12-seat aircraft crafted for community routes that stretch up to 500 miles. With its modular battery system, it can recharge or swap packs in just 15 minutes, meaning more time in the sky and less time sitting idle on the tarmac. The silent electric motors eliminate the noise that traditionally limits airport operations, reopening early morning and late evening slots that were once impossible due to community noise restrictions. Because it uses far fewer moving parts than traditional aircraft, it replaces hangar-heavy maintenance drama with the predictable precision of a factory line. This is where Tesla's formula of simplicity and durability meets aviation. For everyday travelers, it's not just about getting from point A to point B, it's about how comfortable, accessible, and affordable the journey can be. The cabin design reflects this vision perfectly. Rather than cramming rows of seats into a tiny fuselage, Tesla's engineers opted for a compact yet spacious layout, 1-2-1, seating that keeps the aisle comfortably wide at 18 to 20 inches. Enough room for passengers to move without brushing shoulders. Boarding the plane becomes as easy as stepping into an SUV. A large, low-mounted door and short step height mean anyone can board with one hand free, without awkward climbing or bending. That same entryway, around 50 by 50 inches, can swallow standard cargo containers or even emergency stretchers, allowing the aircraft to transform from a passenger shuttle into a small cargo or medical response craft in minutes. Quick-release seat rails make the change effortless, letting operators switch missions on the fly. Durability and ease of inspection take center stage in Tesla's design philosophy. Short-haul aircraft endure countless takeoffs and landings, accumulating structural fatigue and corrosion faster than long-range jets. Tesla countered this with a smart blend of corrosion-resistant aluminum in the main structure and lightweight composite panels for fairings and skin sections. High-stress areas receive double plating, while seams and joints are placed in open sight so mechanics can inspect them quickly without tearing apart the interior. Every recurring maintenance point is positioned for access, not frustration. Even the seats and restraint anchors meet dynamic crash standards, meaning they're tested to protect passengers' heads and hips in rough landings. Far beyond the minimal pull test standards that many aircraft still rely on, the expected service life. Tens of thousands of flight hours before any heavy structural work is needed, a standard that aligns more with industrial machinery than fragile. And the shape of the plane begins to whisper instead of roar. Aerodynamics aren't just for performance. They're for peace and efficiency. The Tesla Super Electric Plane uses clean, smooth leading edges on its wings and advanced tip treatments to cut down induced drag, boosting range and softening the sound waves people hear as the plane approaches. Enclosed landing gear eliminates the typical whistling and rumble of small turboprops. Even the propeller blades are tuned to keep their tip speeds below the high subsonic range, preventing the shrill tones that travel for miles. When you combine those aerodynamic refinements with nearly silent electric motors, community airports can finally expand their usable hours without disturbing neighborhoods. That means more flexible flight times, better reliability, and fewer cancellations due to curfews. Underneath its skin, every part of the aircraft follows one rule serviceable first. High-use systems like the inverters, motor controllers, avionics, and climate modules are arranged like plug-and-play units. Each one sits behind dedicated panels that open with standard tools, not buried beneath trim or seats. Every module connects with keyed color-coded connectors, so there's no confusion or guesswork. A two-person ground crew can remove and replace a major component in 5 to 10 minutes, right on the ramp, without special equipment. Fasteners are standardized throughout the airframe, and every system is tagged with a QR code linking to digital manuals and its entire maintenance history. Even the battery modules follow this same design logic. They slide into place, guided by rails and secured by safety interlocks that prevent accidental disconnection. The full energy swap fits within Tesla's 15-minute turnaround promise, a figure that transforms the economics of short-haul aviation, and that's where the Tesla Super electric plane completely reshapes flight schedules. Instead of long, unpredictable downtimes, every minute on the ground becomes a measured, repeatable process. Park, unload, reload, swap the battery, run automated system checks, and take off again, all within a quarter of an hour. Boarding takes 2 or 3 minutes since only a handful of passengers are involved. Bags are loaded in parallel. Battery swapping consumes about 6 to 8 minutes, and the remaining time goes to pre-flight checks. Compared to the 25 to 35-minute turnarounds of today's small regional planes, Tesla's 15-minute cycle adds breathing room to every flight, not pressure. With tighter cycles, each plane can complete more legs per day, 10 to 16 short hops if the routes are within 250 miles, or 6 to 10 if stretched to the full 500-mile range. Instead of waiting around on the tarmac, Tesla's aircraft spend their day earning, flying more passengers, and keeping schedules intact. But the real transformation isn't just in operational, it's math. It's in how travelers experience time. Today, many regional drives take 3 to 5 hours once you factor in traffic, stops, and city congestion. Tesla's short-haul aircraft compress that to as little as 90 minutes door-to-door, including check-in and transfers. That's possible because the plane uses community airports, smaller, less crowded hubs scattered across thousands of towns and regions. There's no long taxi, no endless boarding queue, and no connection through a major hub. You simply arrive, board, and go. These smaller airports have long been underused. Tesla's quiet and compact plane allows them to host regular commercial service without disrupting local life. This decentralizes travel, putting genuine regional mobility back in reach for everyday people. Quiet operation also unlocks more flight hours in the day. Traditional turboprops often face curfews because of the noise they generate. Tesla's silent electric motors and optimized aerodynamics allow operations early in the morning and late into the evening. Airports can now schedule flights during periods that were previously restricted, giving passengers better departure options and airlines higher utilization rates. The result is a smoother, more flexible timetable that keeps on-time performance consistently high. Behind this entire concept lies Tesla's obsession with simplicity and long-term savings. The electric powertrain at the heart of the plane eliminates one of aviation's biggest cost drivers: complex mechanical components. The direct-drive electric motors skip gearboxes entirely, removing dozens of moving parts that typically require constant lubrication, inspection, and replacement. This drastically cuts vibration, simplifies maintenance, and extends component life. In cruise flight, the motors and inverters reach efficiencies between 90 and 95%. Meaning almost all the stored energy becomes thrust instead of wasted heat. Each motor runs independently, so even if one unit encounters a fault, the plane can continue flying safely without interrupting the schedule, a redundancy that builds resilience into every route. The energy system itself is modular and built for rapid replacement. Instead of a massive, single battery slab, Tesla uses smaller modules that can be swapped individually. Each module is cooled through a precise liquid cooling network, maintaining temperatures between 15 and 35 degrees Celsius. the sweet spot for both safety and battery health. The result is predictable, repeatable, range performance, and longer packed lifespan. Tesla's target is between 600 and 900 kilowatts of total capacity, translating to around 500 miles of range with payload. The energy density sits around 360 watt-hours per kilogram, high enough for strong performance, yet manageable for cooling and maintenance. Cycle life is equally important, with between 15